All right, so in section 1.5, we introduced the idea of nested quantifiers. This would be where you introduce a variable and then it has a scope. And then within that scope, you introduce a second variable and it has a scope. And then you say some things that involve potentially both variables. In this section, we're going to start working with predicates that have more than one variable. This is like a function of multiple variables. You don't need to have taken multivariable calculus or something like that to understand this. It's basically the idea is you have more than one input, and the truth value of the predicate depends on the value, the particular domain elements for the two inputs. So the example here is we're going to use the domain of all living people, all people who are alive. And I'm going to define this predicate L of x and y, right? It's two inputs, and it's x loves y. So if x loves y, it's true, right? Depends on the two people in question. And then I'm going to define another just one-dimensional or function of one variable over here. A of x means x is alone. We're going to use that only on the last one here. So, playing the same game as we did in the last video, we're going to try to translate back and forth between verbal statements and symbolic statements. So I want you to give this a try. I know I haven't really taught you much about this section yet. I had originally planned on doing this exercise at the end, but I decided to do it first because I think it might be good for you to try this and see if you can figure out how it works on your own. And I'll explain the answers here. And then I'm going to go into a little bit more detail about like the concept behind how it works when you have two variables and you're nesting them like this. So, okay, go ahead and pause the video, see if you can figure out what this is, what's going on here. I'm now going to walk you through it. You can hear my dog moving around in the background there, sorry. All right, so the first statement is verbal. It says, there are two people who love each other. All right, so there are two people. Those two people, we're going to call them X and Y. Now, there are. That sounds like a there exists. That's claiming the existence of two individuals in the domain. So I'm going to start by saying there exists X and there exists Y. Okay? So you could even think of it as there exists X such that, there exists Y such that, and then I'm going to say something about those two people. Now, one thing I want to say about those two people is that X loves Y, but it says they love each other, right? So I'm going to say L of XY for X loves Y, but I also want to say, because loving someone is not necessarily something that is reciprocated, okay? It's not necessarily, that's called a symmetric relation. It's not necessarily symmetric, because you can love someone and they might not love you back. I know, hard truths of life. So I need to say X loves Y, and in order to say that they love each other, I also have to say and Y loves X, so L of YX. I'm swapping the order of these individuals in order to indicate love going the other direction. Now there's one more problem here that we would address, and it's not exactly a problem, this is a good thing. You can love yourself. I hope you do. A person can love themselves. L of XX could be true, all right? X and Y could be the same element. And what we want here, I think it's clear, sort of implied, but I think it's clear in the statement that these should be two different people. It says two. I think it's pretty clear, right? It's pretty much, it's not even implied. Two people. So we need to make one more statement here in order to verify that these X and Y have to be different. I'm just going to include another and say X is not equal to Y. You can always use the not equal operation here for elements of a domain. Like that is something you might have to define if you were doing some object-oriented programming. You might need to define what it means for things to be equal or not equal, but we're going to assume that we already know that. So in this case, two people not being equal to each other just means they're not the same person. That's pretty obvious. All right. So that's how you can represent that one symbolically. Let's move on to the next one. This one says, there exists an X such that for all Y, L of XY and not L of XX. Remember how I said a person can love themselves? Well, in this case, we're talking about a person who does not love themselves, right? We're saying not L of XX. They don't love themselves. So this is saying there exists an X, or there exists a person, such that for all people Y, X loves Y, and X doesn't love X. It might make more sense to use, instead of the word and, it might make sense to use the word but here, because it's followed immediately by a not, right? So there's a person such that for all people Y, X loves Y, but X doesn't love X. Okay, so I think what this is saying is that there's a person who loves everyone except themselves. That's what I'm going to write over here. There is a person who loves everyone except themselves. I think that's what that's trying to say. But I just realized as I was explaining this that I wrote it wrong. So I'm going to fix it. That was what it was meant to say, and it almost says that, but there's a problem. And I'm going to go ahead and explain the problem before I move on, because I think it's a good learning opportunity. The problem is, this claims for all Y. That really needs to function, that really needs to be validated for all elements of the domain, including X themselves. So this person X, they count also as a possible value of Y, right? So in that case, we would actually end up with, when X and Y are equal to each other, we'd end up with a contradiction. So no matter who you pick, no matter which X human you pick, this needs to be satisfied for all Y, and then when X and Y are equal to each other, L of XX and not L of XX is false. So actually, this is not satisfied by any person. This whole thing actually is false. It's equivalent to false. It's a contradiction. So that was a mistake on my part. I'll write down a different version, which was what I kind of meant to say. I meant to say this. There is a person who loves everyone except themselves. And that would be, there exists X such that for all Y. First of all, let's lead with this part. They don't love themselves. Not L of XX. And then, if Y is not equal to X, okay, if you're talking about any other person, then, and I'm going to put this in parentheses, like this, then they do love Y, L of XY. There we go. So I think having fixed it that way, I think that actually fixes what I was meant to do. Fixes it to be what I meant it to be. There's an X such that for all Y, first of all, X loves themselves, and when Y is not equal to X, X loves Y. So that means this is showing that they love everyone except for themselves. All right, sorry, let's move on. Let's move on to everybody loves Raymond. I threw this in there, obviously, just for the jokes. But this is a pretty straightforward one to use. We can use Raymond as like a constant element of the domain. And to say everybody loves Raymond, everybody is a universal statement, right? So we'll say for all X, for all humans X, all I need to say here is X loves Raymond. So L of X, comma, Raymond. And this would include Raymond himself. So I'm imagining Raymond probably loves himself. But this says everybody loves Raymond, including Raymond. So there we go. Now let's talk about the last one. The last one here is quantified universally in both cases, for all X and for all Y. So this is a statement that's supposed to be true for any two people, including possibly a person with themselves, except that part of our implication statement that we're giving here, part of the hypothesis is if X is not equal to Y, then not L of XY. So this part of the hypothesis, if you do have, let's consider if X and Y are equal to each other, if you're talking about a person paired with themselves, then actually the hypothesis here is going to be true vacuously. So that would actually mean that they would have to be alone. Oh, shoot. This is tricky. Folks, this is hard. I think you probably concluded that already. I'm going to insert another thing. I made another mistake. I'm going to insert one more thing, which is inside the hypothesis here, I'm going to have to rewrite it. I want another inside the hypothesis. I want another x not equal to y. So I want to say for all x and for all y, if x is not equal to y, and whenever x is not equal to y, no. Oh shoot! I might have to think about this and make a second video. What I'm trying to say with this is, I'll tell you what I'm trying to say, and then maybe you can help me fix it. If a person loves nobody else, okay, so what I'm trying to say is, if there's a person, or not there is, but like for any person, if they love no other people, right? If you take any other person that's not them, then they don't love that person, right? X does not love Y. If that's the case, then they are alone. Which, you know, has nice, deep, sympathetic resonance. Has nice, deep, resonant truth to it, doesn't it? If a person loves nobody else besides possibly themselves, then they are alone. So I think I messed it up. I messed it up because of the possibility of x and y being equal. And I think that messes this up. But otherwise, I think it's fine. So maybe you can help me fix that to address that problem. And maybe we can talk about that in class. If anybody figures that out, let me know, and I'll make a note about it and let everybody know.